Well, we claim that when we change numeraire from G to H, doesn't matter if we're looking at the price process, we're looking at a process of, for example, an interest rate, which is not a price, but it's but it's a process that related to the price in the sense that they have the same risk factors. So we claim that even that variable we're looking at is not price, it follows the same form for us to change the drift, to change from one numeraire to another numeraire. Now, let's take a look at why that is the case. We're following an approach by John Hall in his technical note 20. This is the link you want to take a close look at it. So basically, what we're saying is, suppose there is a random variable v, which follows a process like this. Now, v is not the price. For example, let's say we treat v as the interest rate, which is not the price, right? But if v is the interest rate, there exists a particular financial asset which has a price that's related to v, right? So a zero coupon bond will be, for example, will have a price, and zero coupon bond is related to interest rate, and zero coupon bond is a function of the interest rate. So if we can think of this as the interest rate, and think of this as zero coupon, the price of zero coupon bond. Now, if you have F, which is the price of an asset that follows a process like this, V, which is the value of something, not a price, that follows this process here. And we know F is a function of V, okay? Therefore, both of them share the same set of random factors here, random risk factors here. In this case, now, here, if V follows this process and F is a function of V, right? And here is deterministic, and here is the random factor. So that gives the risk, so this is the risk factor here. So dF then by Ito's lemma must follow this, right? Which we can write that in terms of V and in terms of the drift of Vm and the volatility of Vs. So now you basically linked the drift of F, which is mu F, with a form here that involves the drift of V and the volatility of V. Same thing, you can match the second part of here, the sigma F with this part that's related to S and V. So once you have done that, so it provides a linkage between the two, then any change of M, so if you replace this with a delta M, means that the change of M here, how's it going to translate into the change here? So your change of the drift for this is really just change of M times V times this partial derivative here. Okay, so there's a linkage between the change. And as mentioned there's a linkage between the second term here. This part is equal to this. So what happened is you put them together. This change is equal to that, which means we know that df dv times v is equal to sigma f divided by s. So df dv times v is equal to sigma f divided by s. So you can replace this by sigma f divided by s here. And then you have a condition here, which is delta mu divided by sigma, which is the change of the drift divided by change of the volatility of f, is equal to change of m, which is the change of the drift of v divided by the volatility of v. So once you have this condition, you will see that, okay, when I move from G to H, I need to change my drift for F in this way, right? So you change the risk premium from G to H times sigma of F. Well, if this is the case, then you look at delta M, the change of the drift for the a process that's not a price, will also from here follow exactly the same form. So lambda G and lambda H here, the change of risk price, and you change then this times the volatility of V, which is S here. So they have the same form. So you can ignore the difference that, one thing is a price, the other thing is not a price, maybe an interest rate. When they change numeraire, the change in drift will have the same form. Okay, so now because they have same form, this will also be true. So the change of numeraire you can use is this particular form. So once you have this adjustment put into the drift, you are successfully changed from one numeraire to another numeraire. So you have meaning that you have adjusted your process by changing the drift of the process. You are successfully moving from one equivalent martingale whirl with, say, G as the numeraire asset to another equivalent martingale whirl with H as the numeraire asset.